right, good morning. So today we're going to talk about solving rational equations. We've done this in the past, so this is a review, but we're going to need it again to expand, so I wanted to review. When we talk about solving rational equations, we have several steps we've talked about in the past, so let's start with those. Step number one. We're going to factor the denominators. Step two, and this is a pretty important one because we're going to refer back to it. And checking some of your papers over the last week, some of us are forgetting this important step. We need to state restrictions. We're going to refer back to this to determine if something is an extraneous solution. Step three, you want to determine the least common multiple, or of course the common denominator. We're going to use that common denominator to clear the fraction. Try spelling that correctly. There we go. Step five, once we clear the fraction, we're going to go ahead, distribute, and solve the equation. And step six, of course, check for extraneous solutions. And again, that refers back to those restrictions we stated in step two. All right, so that being said, let's move right into example number one today. If we have x plus 4 over 6 minus x plus 1 over 3 equals 2. All right, so everything's factored. We don't have to do step one. Step two, we have to determine the least common, Step two, we state any restrictions. Well, there are no variables in the denominator, so in this case, there are no restrictions. Step three, we determine the least common multiple, or greatest common denominator. In this case, the greatest common denominator, 6 is 3 times 2, and we have a 3 in this one, so our greatest common denominator is 6. We're going to multiply or clear the fraction by multiplying by 6 to every fraction. And that includes this one. I know it's not a fraction, but remember it is 2 over 1. But technically it is. All rational numbers, rational functions, rational expressions are fractions. Okay, so in the first one, when we clear the fraction, we're going to cancel that factor. It leaves us with this x plus 4 minus. In this one, in 6 and 3, 3 goes into 6 twice. So it's 2 times what we have in the numerator, which is x plus 1, equals, and here, there's nothing to cancel with the denominator, so we have 12. Now let's go ahead and distribute. We have x plus 4. Here we have a negative 2 in front, so negative 2 times x is negative 2x. Negative 2 times 1 is negative 2, equals 12. Combining like terms, we have an x and a negative 2x for a negative 1x. We have positive 4 and negative 2 for a positive 2, equals 12. Moving our number, our constant, to the right, we're going to subtract 2 from both sides. So we have negative 1x equals 10. Dividing by that negative 1, we get x equals negative 10. And in this case, there were no restrictions, so this will be our final answer. Let's try another example. Of course, let's make it a little bit tougher. Example number 2 today. We have 3 over x plus 4 plus 5 over x minus 3 equals 2 over x squared plus x minus 12. All right, so again, step one is we want to factor the denominators. This one's factored. This one's factored. This one is a trinomial. I'm going to draw ourselves a little x over here. Negative 12 on top, 1 on the bottom. Going to give me 4 and negative 3. So this factors to x plus 4 times by x minus 3. Stating our restrictions. In the first one, x cannot equal a negative 4. Here, x cannot equal a positive 3. In this one, it cannot equal negative 4 and positive 3. All right, now we have to determine what's our common denominator. Well, out of these, we have a factor of x plus 4. I'm going to put that here. That takes care of both of these. And we have a factor of x minus 3. All right. Now, technically, we're going to multiply that x plus 4 times x minus 3, excuse me, to everything, all of them, x plus 4 times x minus 3. In the first one, the x plus 4's cancel as we clear the fraction. It leaves us with this 3 times x minus 3. Plus, here the x minus 3's cancel, and we have 5 times the x plus 4 equals. And here we have x plus 4's cancel, the x minus 3's cancel, which leaves us with 2 on the right-hand side. Now we solve the equation. We're going to distribute 3 times x is 3x. 3 times negative 3 is negative 9. 5 times x is 5x. 5 times 4 is 20. Again, we're to the end of the parentheses, so we're done distributing. Equals 2. Collecting like terms, we have 3x and 5x for a total of 8x. We have negative 9 and 20 for a total of 11 equals 2. Subtracting 11 to the other side, we have 8x equals negative 9. And dividing both sides by 8, x equals negative 9 over 8. And we want to leave that as that improper fraction. Now, we have to check to see, is this negative 9 over 8 one of our restrictions? It is not, so this is a good answer. All right, let's try one just a little bit different. How about example number 3? Let's say we have x over 3x plus 3 equals negative 4x over 2x plus 2 plus 3x minus 2 over x plus 1. All right, again, step 1, we want to factor everywhere. In this first one, it's not a square term, it's not a trinomial, but there is something we can undistribute. Always undistribute your greatest common factor. In this case, I can undistribute the 3. Leaves me with x plus 1. And again, if it's easier, you can cross that out. Moving to the next one, we have 2x plus 2 in the denominator. We can undistribute it 2. Again, we can cross this out. And in this one's already factored. Now, there's a couple things we can talk about. If you can reduce any of your fractions, you really should do that at this point. So in this case, you can see that we have this 2, and on the top we have a 4. We can reduce that. This 2 goes into 2 once, 2 goes into 4 twice. All right, so what we really have here is x over 3 times x plus 1 equals negative 2x over x plus 1 plus 3x minus 2 over x plus 1. Let's state our restrictions. X cannot equal. In this one, we have a factor of 3 and an x plus 1. So x cannot equal negative 1. It's what makes the denominator 0. Any place there's a variable. In this one, there's a variable in the denominator. If I set that equal to 0, we cannot have negative 1 as well. And then this last one is that denominator equal to 0. I cannot have a negative 1. All right, so determining our common denominator, we have a factor of x plus 1, and we have this factor of 3. Are there any other factors in the denominator? There are not. So now we can go ahead and clear the fraction. In the first one, the 3's cancel, and the x plus 1's cancel, leaving us with just x equals If I multiply this one by 3 and the x plus 1, the x plus 1's cancel, leaving me with 3 times the negative 2x. And in this one, again, clearing that fraction, I'm going to multiply, let's see, my factors that cancel are the x plus 1, leaving me with 3 times the 3x minus 2. Alright, so this is the toughest step in this whole thing. You have to remember that you're clearing the fraction. You want to get rid of those denominators. That's why we multiply by the common denominator. In this first one, we have x. We're going to distribute. 3 times a negative 2x is negative 6x. And then that's the end of the parenthesis. We're done distributing that 3. Plus, we have 3 times 3x, which is 9x. And we have 3 times negative 2, which is negative 6. All right. Combining like terms, we get x equals negative 6x plus 9 is 3x minus 6. Moving our x's to the left, I'm going to subtract my 3x. X and negative 3x is negative 2x equals negative 6. Dividing both sides by negative 2, x equals 3. And again, we need to check to see, is this one of our restrictions? It is not. So this is a good answer. Now, if you would have missed canceling the top and bottom, it just means when you're all done, you're going to have to probably reduce or have something a little bit smaller. All right, let's move on to example number 4. If I have x plus 7 equals 25 over x. All right, so this one seems pretty straightforward, right? Everything's factored. Stating our restrictions, the only restriction or variable we have in the denominator are x here. It's just x, so x cannot equal 0. Our common denominator, since this is the only denominator there is, we're going to multiply everything by x. Here, x times x is x squared, plus x times 7 is 7x equals, and here our x's will cancel, leaving us with 25. Now, we have a quadratic here, which means we set the whole thing equal to 0, right? Remember, there's square terms, so we want to get the whole thing set equal to 0. So I'm going to subtract 25 to the left-hand side. All right, now we have to solve our quadratic. You can check to see if it's factors. We can complete the square, or in this case, we're going to just do the quadratic formula. Factoring-wise, if I put negative 25 on top and 7 on the bottom, are there two factors of negative 25 that are going to add to 7? No. So we know this is going to be irrational. So using the quadratic formula makes the most sense. So we have negative b. Well, actually, let's do this. Our a value is 1, our b value is 7, and our c value is negative 25. All right, negative b, which is negative 7, plus and minus the square root of b squared minus 4 times a times c all over 2 times a. All right, simplifying underneath the square root, we have 49 plus 100, or the square root of 149. We get negative 7 plus and minus the square root of 149 over 2. So in this case, we actually get 2 answers that will work. Neither one equals 0, so both of these are good answers. All right, example 5. A couple more to go. In example 5, we have 3x over x minus 2 minus 3 over x plus 5 equals 4 over x squared plus 3x minus 10. All right, again, first thing we're going to do is factor everywhere. So in this one's factored, this one's factored, if I draw myself a little x over here, negative 10 on top and 3 on the bottom, give me 5 and negative 2. So I have x plus 5 and x minus 2. All right, let's state our restrictions. Make this just a little bit nicer there, huh? All right, so in the first one, x cannot equal 2. In the second one, x cannot equal negative 5. And on this side, we have x cannot equal negative 5, which we have, and x cannot equal 2, which we also have. All right, determining our common denominator. We have a factor of x minus 2, right? We have a factor of x plus 5. Are there any other factors we need? That's it. So we're going to multiply every fraction by this x minus 2 times x plus 5. Or sometimes in class we said, what factor is it missing? And we did it that way. All right, in the first one, the x minus 2's will cancel. I will have 3x times x plus 5. In this one, the x plus 5 will cancel, so I have minus 3, don't want to forget that negative in the middle, times x minus 2, equals, here our x minus 5 cancel, our x minus 2's cancel, and we're left with 4. All right, so now we're going to go ahead and distribute. 3x times x is 3x squared. 3x times 5 is 15x. End of the parentheses, so we're done distributing the 3x. Now we have negative 3 times x is negative 3x. And negative 3 times negative 2 is positive 6 equals 4. Combining like terms, we have a 3x squared. 15x and negative 3x is 12x plus 6 equals 4. And again, we have a quadratic, which means we need to get the whole thing set equal to 0. All right, so I'm going to subtract 4 to the side. So we have 3x squared plus 12x. Subtracting 4 gives me plus 2 equals 0. Using our quadratic formula again, not quite that far, we have a equals 3, b equals 12, and c equals 2. All right, so negative b, which is negative 12, plus and minus the square root of b squared minus 4 times a times c all over 2a. Simplifying underneath the square root, we have 144 minus 24, or we have negative 12 plus and minus the square root of 120 over 6. Simplifying 120, that is 4 times 30, and 4 means a 2 can come out. So I have negative 12 plus and minus 2 root 30 over 6. And I can reduce that all by 2. So 2 goes into negative 12, negative 6 times. 2 goes into 2 once, and 2 goes into 6 3 times. So our final answer here is negative 6 plus and minus the square root of 30 over 3. And again, checking our restrictions, this is a good solution. And we have 2 of them that will work. All right, so we have one problem left to talk about. I'm sure you guys have looked forward to the end here. The last problem we have is a wonderful word problem. So this is example 6. All right, so example number 6, we have an open top rectangular box, has a square base, and it will hold 90 cubic centimeters. Each side length is x centimeters, and the height is y centimeters. Express the surface area as a function of the length x of the side. So let's put this all together. First of all, it's saying we have an open top rectangular box, and that it has a square base. So if I have a square base to my box, I'm trying to sketch that here. All right, there's my box. It has an open top. It has a square base, and the side length is x, so we have x and x. And then it tells us that the height is y. It tells us that it holds 90 cubic centimeters. All right, so if we're holding 90 cubic centimeters, that's the volume. So we're going to start by saying we have 90 equals length times width times height, or x squared y. All right. It then goes on to say to express the surface area. So this is the volume we're talking about here. We need to talk about the surface area. Surface area is the outside part. And in this case, if we're writing an expression, which means there's no equal sign involved, the surface area is the area of each side. And again, it's an open top. So the bottom is x times x, or x squared. Then the sides are each x by y, or xy. Now, how many sides are there? There are 4 xy sides. Now, whole idea is just express the surface area as a function of x, which means we need to get rid of y. Over here, we use this volume, and we can solve for y by dividing both sides by x squared. So I get y equals 90 divided by x squared. I can substitute this in to my expression I'm making over here. So I have x squared plus 4x, and replacing y with 90 over x squared. Now I just simplify. I have x squared plus my x's can reduce. So I get 360, 4 times 90. X is reduced over x. This is the expression written by x. All right, so your last problem in your homework is just like that. It's going to lead us into the next part. So if you have any questions, please let me know. Show all of your work today. It's very important that I see those things, and don't forget your restrictions. Good luck, guys.